I'm gonna try example 1 a little bit differently than the way I taught it period 5. I want to skip letter A for a minute. Go back to what you did in the beginning of this lesson with shading grids. We have 100 boxes. If I want to shade 17%, how many boxes am I shading? So let's do that as quickly as you want. If you want to, here, can I show you a shortcut? Because we are pressed on time. Just put a line through the boxes you would shade. There's 10. There's 17. It's just a quicker way to do it. All right? What about 83%? How many boxes would you shade? Obviously, 83. Tell me, does this confuse you? I'm going to shade 83, but I'm going to shade 83 backwards. I'll explain why here in a minute. There's 30, 40, 50, 60, 70, 80, 1, 2, 3, 83. See what I did? The reason why I'm showing it this way because 83 plus 17 adds up to 100. So whatever I was not shaded in the 17% is shaded in the 83%, just so it's a little bit more visual for you. Okay. Now, before we go on to B, again, if I'm shading 17%, how many boxes did I shade? Okay, so each box is worth 1, right? 83%, how many physical boxes did I shade? Each box is worth 1, right? What if I now tell you that instead of these grids representing 100, they represent 600? If you think about it, it's kind of like a big, huge tape diagram, because we've done something like this with tape diagrams. So if now each box is worth 600, what's the value of each box? Don't guess. Remember, when it was 100, each box was worth 1. Right, it's 6. It's like when we used to do tape diagrams, going back to lesson 3, lesson 4. If I told you that this had to add up to 21, each box magic number 7. It's the same thing. I'm asking you to find the magic number if this is now worth 600. So each box, now I'm going to go back and that kind of answers question 1. Each box is worth 6. Good. So I know what you're thinking, Jack. You're right. But for right now, keep it 6. Okay. So, ready? Here comes the leap. See if you can figure this out. If I shade 17%, and you told me before we made this 600, when it was worth 1, and we shaded 17%, how many boxes did we shade? What was our value? 17, right? Now I'm telling you each box is worth 6. There it is. There's the connection. So to try to figure out what 17% is of 600, we're doing 17 times 6. Let's do that. And then I'll breathe some life into it in a real life scenario to see if this even makes further sense. So go through the math. Make sure you multiply correctly. 17 times 6. I did the dot. I did the dot for multiplication. Don't let that confuse you. Our all-star student in the first quarter, what'd you get? Did you get, not percent though. 102 is the value of 17 times 6. Did you get 102? Let me see if I could breathe some life into it in a real life scenario, because it's pretty darn close. All right, hold that thought. Make believe there are 600 students at Nesquik. It's actually a little bit less, but it's not too far off. 600 students at Nesquik. 17% of them are going on a field trip. How many students are going on the field trip? Abigail. 102. You just did what's called percent of a number greater than 100. Okay? So now how would you figure out how many students are not going on the field trip? What would you have to multiply to figure it out? 17%, let's do a percent first. 17% are going on the field trip. What percent are not going on the field trip? What percent are not going on the field trip? You could do that. She said subtracts 102 from 600. How would you do it, though, using percentages? Paul. We did that for the ones that are going on the field trip. You did the percentage times the whole, right? You did the percentage times the 6. So what do I have to do using multiplication here? 83 times 6. So do that. Now, Francesca said we could take the easy way out because she realized she's starting to make that connection. A part plus a part makes the whole. Well, if we have one part, 102 plus the second part has to add up to 600. That's a good way to check it, by the way. There's more than one way to do it. 83 times 6, what do you get? 498. Now we're going to use part, whole to check it. If you add them, what are you supposed to get? The whole. Part plus part equals whole, always. Michael. To check our work, part plus part has to equal whole. Here, let me raise this up. And then watch what I'm going to do on below it. The 17%, which I'm going to put above here, was 102 plus 83% was how much? 498. Which equals the whole, which is 100%. So look, I showed it to you here. You still have like a template, but it's in the middle. The part plus the part equals the whole. As percentages, 17% plus 83% equals the whole percentage, 100. But it's the actual numbers of who's going on the field trip, 102, plus the ones not going on the field trip, 498, equals the whole entire school of 600. Yeah, because I think he could definitely do it this way. It actually goes beyond explanation because it really shows how everything part plus part equals whole. No, if you want to put it into words, you could say, how do you check your work? The two parts, 102 plus 498, have to add up to the whole 698. Eric. True, fair point. You're right. Just got to be careful with it, yeah. Jack. As a percent, 100% of 600 students is 600 students. Okay? All right. So now here comes the shortcut. Oh, this shows it to you also as TRP. Let's just do it. It's still part to whole. It's worth modeling it, absolutely. Remember that when you have a percent, you automatically have an entire ratio. This 600 was the part of the whole. See where that 17 times 6 came from? There it is. 102 was the answer for that, right? It doesn't work. That's the only problem with is over of. Is over of we've abandoned because if they give you, it doesn't work. It's a way that we used to teach it, but we ran into issues. We really ran into some issues. It's hard to explain because when it gets to the money, it gets problematic when they ask you to find what the total bill was. Okay. 83 over 100 was our percent equals 600 hasn't changed times 6, and you get 498. All right. that being said, now that we've made the connections with the models and the templates and the ratios, there's still an easier way to do it. Because what will happen is if you use TRP or you use grids, if you wind up getting an answer of like 21.6 as an answer, there's a lot of steps to get to that answer. So there's actually a shortcut that if you choose to do it this way, you can still get full credit. And that is take the percent, change it to a decimal, which you can do, and multiply it by the whole number, and you'll always be right. So for instance, 17% of 600. What's 17% as a decimal? Just say 0.17, right? However, I want to put the number that has more digits on top, just like whenever I do any multiplication. So 600 will be on top, and I'm going to multiply times 0.17. What should I get? 102. We should get 102. 7 times 0. 7 times 0. 7 times 6. Okay. 1 times 0. 1 times 0 again. 1 times 6. Now don't forget, how do I know how many places to move the decimal? Sarah. And no places here, right? So 2 total jumps. 1, 2, ta-da, 102. Works. Okay, and it will work every time. Oh, what's 83% as a decimal? Okay, 3 times 0. 3 times 0. 3 times 6. 8 times 0. 8 times 0. 8 times 6. Uh-oh. Times table snipers. 48. Leap it how many times? 1, 2, 498. So can I just tell, before I set you guys practicing on your own, another reason why this is the better method, as you'll see it in advanced, when advanced moves on, you'll get something like this. What's 16.3% of 24.2? If you try to do this using TRP, man, it's a lot of work. But if you do it as straight multiplication, change this to 0.163, and then multiply it by 24.2, you'll get it right every single time. All right? All right, I think this is where we split up, I think. Some of you are going to be doing advanced, and some of you are going to be, let me